Hi, this is Chong Kim, and welcome to Chess in Ruby. And in this version, we're going to refactor. And instead of refactoring the code, I think that it's best if I rewrite the code because it's only about 200 lines, so it's not a lot of code, but it's very different. My assumptions and my thinking has changed since I've written the code. So um, this will be kind of interesting to see how I would write the code now that I've experienced how things are being used. So what I'll do right now is I'm going to remove all the files, the spec and the code. I'll leave the games there, and I'll start from here. So we'll start again with chess spec. And oh, actually, okay. Set this up so that it'll automatically run rspec. All right, so we started off just like as before. So require the chess and describe position. PO for position and SB for subject. Okay, so we have position and we have the same properties. So the board this time around, initially I had it set to be a blank board, but I didn't find that that useful. So what I'll do is I expect it to be the full set, the setup. So rook, knight, bishop, queen, king, bishop, knight, rook. And then from here it is, oops, 8 pawns. And we have 8 dashes. We get 4 of these in a row and 8 white pawns. And then we get rook, knight, bishop, queen, king, bishop, knight, rook. Okay, so we have the board that it should look like this, and the turn should be white. Okay, that doesn't change. Castling is still the same. King, queen, king, queen. En passant, it's going to be nil. Half move, 0, and full move is 0. Actually 1. Okay, so let's get this thing to pass. So we're going to edit the chess RB. Okay, so we create the class position, and actually we need to set these up here. So we have the board, the turn, castling, en passant, what else? The half move and full move. Okay, and okay, so we set the board. Instead of copying and pasting, I'm doing this again because if I made a mistake, then this will catch it. Sort of like typing your password twice to verify that you got it right. Okay, so 8 pawns, 8 dashes. Okay, 8 regular pawns, white pawns. So rook, knight, bishop, queen, king, king, bishop, knight, rook. Okay. All right, so that takes care of the board. Turn is white, castling, set to be king, queen, king, queen. Okay, so all of them are set. En passant is nil, and half move and full move. Okay, so this should pass. Okay, great. So so after creating the board, I'm going to start with what I think should have had more importance, which is the function move piece. Originally, move piece was just a glorified assignment statement. It was just basically two statements: assignment and clearing out the previous the original source position. So instead, this is going to have a little bit more logic in it, because when we wrote move, that had too much logic, and that was there was just too much to keep track of in there. And so instead, I'll make moving the piece a responsibility of move piece here. And okay, so let's see. So move. Okay, so what we want it to look like is we want to be able to make a position like rook e4 and say move piece, lowercase piece. And oh, this is another thing. Before I had used keys like e4 to, let's say, e2, but instead I'm going to make them into functions. There's going to be a function called e4 which returns the index position of e4. So instead of having two sets of coordinate systems, one being like e4 and the other one being a number like 36, and then converting it back and forth, I'm just going to have it just all being integers. But I could still have the functionality of using keywords by just having a function name e4 which evaluates to the index position. So this, when we do this, this is going to equal the position rook e2. The rook will be on e2 when this is done. So let's try to make this thing pass. Okay, okay, so we have to create a class function for bracket. So let's go here, and so it's self bracket, and it takes in a string. And what it does it'll create a position, but it will set the board to be blank, 64 of them. Okay, times 64. Okay, and we'll specify that this is for the board. Okay, so we're going to create a new board that's like this, and then now we'll just go through the string. So string, we split it up into words and go through each one. And when, actually it's case. Case, when we see what looks like a piece, so rook, knight, bishop, queen, king, and we'll put a question mark because it'll default to a pawn if we don't specify, and then the location, so A through H, 1 through 8. Okay, so if it looks like this, then we want to set the board position of that. And if we evaluate $2, then that'll give us the position. And the piece will be $1. Okay, so the first capture. And if it will default to a pawn. And we'll send it the function fn, which we'll define as uppercase. So it starts off being uppercase, meaning for white pieces. And when we see 2 dots, we'll set the function to be downcase. Okay, so this is not very different, except for probably this and the way this is being set up. Oh, the other thing too. Oh, actually, okay. Let's make this pass first. Okay, so unexpected input. Okay, so we're missing an end. Oh yeah, we're missing an end for the case. Okay, so wrong number of arguments for the constructor. So we'll just make a small little test here. So so it'll be for new and ops. Okay, so for the ops, we would new and let's say turn black. Oh, forgot parentheses, and its turn should be black. Okay, so something pretty simple like this. Okay, so we'll go back here and pass in ops. Okay, this is much more simplified than before because we initially we passed in, I think we passed in the board before, but now it's just going to be ops like this, and we'll just default it. So ops, actually I'm doing the wrong place. It starts from here. So ops of the board, and defaults it to that. Okay, line this up, and ops turn, default to white, ops castling, and ops en passant, ops half move, ops full move. Okay. All right, so undefined local variable E4. Okay, so now E4. Okay, the way we're going to handle E4 is we'll create a module, and it'll be part of the chess helper. So, okay, so it'll be, I'll do an example for E4, but E4 to equal some number. I think it's 36. If I'm wrong, okay. Actually, let's do something that we know. So we know that A8 is the first square, so that's going to be 0. And, well, A7, the one next to it, should be, oh, actually, that's not the one next to it. B8 is the one next to it, and that should be a 1. And below A8 would be A7, and that should be 0 plus 8, so 8. Okay, so that's what we should expect. And actually, in this case, this will really be coordinates, not just E4. Okay, so uninitialized constant chess helper. Oh, actually, before we do that, we include chess helper here. Okay, so we go back here and we create module chess helper, and we're going to go through a loop. Actually, let's just save this, and it says A8 doesn't exist. Okay, so what we'll do is we'll create a bunch of functions. So instead of doing it like 64 of them, I'm just going to put it into a loop. So I'm going to say it's going to go from A up to H. Each with index do. Okay, so the first argument, the accumulator is at the end. Not the accumulator, the index is at the end. So the first one would represent the file. In chess, the column is considered the file, and the row is considered the rank. So that's the file, and there's some number associated with that, the index position, and we're going to go from 8 down to 1, each with index do, and that would be the rank, and I'll just have it as R. Oops. Okay, rank R. Okay, so we want to use define method, and we give it a string. So the name of the function, the function's name is going to be the file with the rank. So like A7, for example. Okay, so that's the name of the function, and what will it do? Okay, went a little bit too far. Okay, so for the block, it will return the file plus rank, but the rank is multiplied by 8. So that's all it does. Okay. All right, so actually, we could have also just did it this way. So basically, rank and file is the same thing as this formula. Okay, this should give us a position into the index. Okay, okay, good. So it looks like that passed, and now we're up to undefined method move piece. So we'll create a move piece. And the it'll take from and a to. Okay, so so given a board, it will uh, 2 is equal to board from, and where you're coming from, we're going to initialize it to an empty space. So keeping it simple. Oh, actually, and then return self. So it can be chainable. Okay, so undefined method move piece for, oh, this is interesting. We just created move piece here, and let's see what the error is saying, because it shouldn't have said undefined method. Okay, it's for an array. Okay, the reason why is because of the bracket. Okay, let's go back to the bracket. So for this bracket, it creates a position, it sets up the position, but we were supposed to return the position. So that's what the problem was. Okay, so okay, one of the problems we have right now is that since we're comparing two positions, the output is terrible to look at. So what I'll do is I'll create a function so that we'll overwrite inspect so that it uses fen. Fen is Forsyth-Edwards notation. It's just a chess notation to represent the board. And okay, so the board will look like, we'll break it up into slices of 8 rows and map it so we end up with rows. And for the first row, we'll just join it, and then we'll join it with slashes for the rows. Okay, and just to get this thing set up, we'll just print it out for now. So this is what it looks like. But to make this a little bit more compact, instead of, we're going to replace the dashes with the number of dashes there are. So we'll just go in here, and G sub will look for dashes. The plus means more than one dash. And we're going to replace that with the size of the number of dashes. So now we have this. It's almost there, but it would also be good to have all the other information as well. So for example, we have the castling. So if actually the next thing would be the turn. So it's depending on, okay, whose turn it is. If it's white's turn, then we want to show a W, otherwise a B. Okay, and castling is if it's empty, we want to give it a dash, otherwise we'll just join it together. Okay, and the en passant. Okay, so it just defaults to a dash if it doesn't exist. Oh, and okay, actually this is not it. Okay, we'll say en passant. If it exists, then we're going to convert it to a square. Otherwise, it'll be empty. Okay. The reason is because EP will be storing an integer, because throughout the whole program we'll be using integers instead of symbols. Okay, and then you have the half move and full move. So we'll just put these things in now. T, the castling, en passant, half move, and full move. Okay. Undefined method white. Okay, so now we just create a method for white. So white of white, that should be a 1. white of black should be in 0. White of, I'll just leave it like that. Okay, nil actually, or anything else should be nil. Okay, this is the same as before. And then white of a capital R is going to be a 1. White of lowercase r is going to be 0. And white of dash will be nil. Okay, so this should be complete for white. And then we create the function white at the very top. And say piece. Okay. Case piece when it's uppercase. Or white, then we give it the white value. When it's lowercase, then it's going to be black. And otherwise, we just leave it alone. Okay, so what we have is two positions that are the same, but they're not being equated the same. The reason is because by default, if you don't override the equal, it will just check if they're the same object, and they're not the same object. You want to compare the values. So we're going to override equal so that this will work. And instead of hard coding all the attributes, I'm just going to do it in a generic way. So I'm going to say instance variables. So this gives us a list of all the instance variables, and we're going to go. We're going to say, are all of these true? So we have a variable, and instance variable get. Okay, and we get the variable, and we see if that's equal to instant. Oh, not self, but the other. Instance variable get of. Okay, so it checks to see if all the corresponding instance variables are the same. Okay, this time everything passed. So far, so good. All right. So we have move piece set up so that if you're able to move a piece, then this works. But we also want move piece to handle the special cases for castling and en passant. So okay, before, when we had the logic for castling en passant, it was kind of all over the place in different areas, and so I just want to have it all in move piece. So let's start with a position where we're dealing with a castle. So king is on e1 and the rook is on h1. So this is going to be white kingside castle. Oh, okay, so then we're just going to move the piece, and castling is actually considered a king move. So we're just going to move the king from e1 to g1. And we expect that the position will look like a king on g1, and the rook is going to be on f1 now. Okay, and what else is that the state is going to change. So the castling will now have, instead of it being king, queen, it's going to have it without the king because we just castle kingside. Actually, both of them, because we've already castled, so white doesn't have any castling options. Okay, so let's see what happens if the king castles on the other side. So king, there's a rook on a1 now. So that would be c1. And so what we'd have is a king on c1 and the rook is on d1. And the castling situation is both the same. And okay, so this shows what happens if you do a king move for castling. There's actually some other rules about castling. So if you have a king and a rook, let's say, and you move the king from e1 to e2, so you're not actually castling, but you're just moving your king, then the position is going to be king e2, and the rook is still on h1, but your castling option is gone. So you just have king and queen. Okay, all right. So, okay, so what happens if you move the rook? Okay, so you have this and you move the rook. The rook is on h1 and you move it to h2. Then the king's still on e1, but the rook is on h2. And for your castling options, you lose the ability to castle king side, but you still have the queen side that you're able to castle. And let's just say there's a rook on a1 just to round it out. Rook on a1. Okay. And if you happen to move the a rook, so a to h2, then actually this, see, not a2, right? Then you lose the ability to castle on the queen side, so the king is still there. Okay. All right, so this should handle those situations. So let's just check. Okay, wrong number of arguments to 2 for 1 for bracket. Okay, so let's handle that. So that's okay. So brackets. Okay. So if I do something rook e4, and I should be able to do this. And if I say board of e4, this should be a rook. So basically with no arguments. But if I put some arguments here, and I say rook e4, and say turn, I keep using turn. Yeah, I'll just, oh well, en passant is, actually, I'll just use turn again, is black. Then I look at the turn, then the turn should be black. Okay, so let's make sure that that works. Okay, wrong number of arguments. 2 for 1. Chess 32. So let's go to 32. Okay, so here. Okay, so now it takes in ops which are optional. And what we can do is we can merge it in. So we can say ops merge all the this with the other options, and okay, that should be it. This is much cleaner than before. Okay, all right. So our first thing is when we try to move from e1 to g1. So we're trying to move the king 2 squares from e1 to g1. Then what we see is that the king is moved, but the rook is still at the end. So the rook has to move. Okay, so let's do that. So we're here in move, and we'll have, I'll just put a comment on this called secondary move. And following the secondary move, we have update state. Okay, so secondary move. So what we have is, depending on what the piece is, when it's a king, okay, and if you're going from e1 and going to g1, and and you're white. And see, actually, instead of saying white, I'm going to make this more general. So based on the piece, if you're white, then it's E1, otherwise it's E8. And for the 2, depending on what color you are, it's either going to be G1 or G8. I'll put some spaces in here. Okay, so it's either going to be E1 or G1 or E2, E8 or G8. Okay, so if you're going from that to the castling position, and castling includes, and this is a kingside castle, so what we're looking for is a king. So if you're white, then it's going to be a capital K, otherwise a lowercase k. Okay, then we actually want to do the secondary move, which is to move the rook over. Actually, we could say the board from H1. Actually, we can just say move piece again. Move piece from H1. Actually, it depends. And it's getting a little bit long there, so I think I'll just put it over here. Okay, so you're going to move the piece from H1. Actually, depending on the piece, it's going to be H1 or H8 to, depending on your color, F1 or F8. Okay, so that takes care of that. And okay, so let's see what happens. Undefined method piece. So, oh, piece. Okay, so piece is equal to whatever's in the from. Okay, all right. So for the position matches now, so the rook is moved over, but we need to do another thing, which is to update the castling state. So in this case, depending on the piece, okay, when you move the king, when the piece is the king, then we can get rid of the okay, then actually then it should be castling. We remove or we delete the, and if you're white, it'll be a K. Actually, all of them. Oh, that's right. We need to do 2. So if you're white, it'll be K, or depending on the piece, it's going to be a K or lowercase k. And you're going to do it again. Delete Q or lowercase q, because if you move your king, you lose the ability to castle on both sides. Okay. All right, so let's see. All right, so it looks good because it looks like that one passed, but now we have a different position here. So we have king on E1, rook on A1, and we're trying to castle on the queen side. And so the position is not matching. That's because for the secondary move, we want to say if, okay, actually what we can do is, this part is still the same, the king being on the home position. So I'm just going to keep this and put this under an if. Put this as a then. Okay, and actually I wonder if I can move this over here. Nah. All right. now actually, I'll try to be a little too clever here. Sometimes that's a bad thing. Okay, so from is still white, E1, E8, and now the 2 is different. 2 is going to be, being on the piece, it's either going to be on, okay, you're moving the king over to the, from E to C, that's 2 squares over, C1 or C8, and you are able to castle, so it includes, depending if you're white, a queen or lowercase q for black. Okay, then you're going to move the piece. So if you're white, you're going to move the A1 to D1. Okay, so let's see. All right, so it looks like that is good. Now this is a different situation here now. This, you're moving a piece from H1 to H2. So now you're moving a rook. So if you move a rook, you can see that the position is right. So we don't have to do anything about the position. But for the state, you lose the ability to castle on the king side if you move the king side rook, which is the H1. So let's do that. So that's for the updating. So now it's the case of when it's a rook. Then if the target square, if you're going from, actually, yeah, from is H1, and castling, actually, we can always say to remove it, because if you remove something that's not there anymore, then it wouldn't really make a difference. So we can just say castling, delete, and if you're white, based on the piece, if you're white, then you want to remove, this is a kingside castle, so it's a capital K or a lowercase k. Okay, if where you're coming from is H1. And okay, so let's see. Okay, that's good. And now this one is for the queen side, so let's just do the queen side. So it'll look exactly the same, but with the change of this being on the queen side. All right, so everything passed. So now we have, so this little piece of code, even though it's it looks long-ish, the logic is very clear. Just some assignment statements, some if, and this is not as complicated as what we had before. So we're trying to separate the responsibility between move piece and move. Okay, so we have, okay, so now we have to handle en passant. So if you have a position where there is a pawn on e5 and a black pawn on f5, with the en passant square being on f6, then you make a move. Okay, so if you make a move from e5 to f6, you should be allowed. Okay. Okay, so the pawn is going to be, there's only going to be one pawn because it would have been taken. And that pawn is on f6. Okay. Undefined to square. Oh, this is, okay, so this is the first time we reached the to square. All right, so we need to create to square of 0 to be a A8, right? And 1, which is right next to it, is B8. And 8, which is 1 down, will be A7. Okay, so now we make 2 square. Okay, so we start with an index, and we take A, and we need to split it up. So y, x, and we use div mod on 8. So if you start with the x, then you just add the a to it and get the character. And then for the y, you do you subtract it from 8. Character. And you take the whole thing, and we'll just turn it into a symbol. Okay. All right. So we have 2 square working now. We're looking at move piece here for en passant. So in en passant, we see that the board is not set up right, and okay, so let's fix up this position. So so the secondary move, in this case, we're in move piece here, and this is part of the secondary move. When it's a pawn, and if the piece, if the original piece, actually based on the piece, so it's a pawn, goes to, right, so if the en passant square, if you're going to the en passant square, and okay, so it's a pawn, and you're going to the en passant square, and you follow the restrictions that the dx, the change in x is going to be 1, and the change in y is going to be 1. So it's actually depending on what color you are. For the absolute value, I mean, for the change in x, it's an absolute value. But then change in y, depending on what color you are. So if you're white, then you want it's going in the -1 direction. And +1 if you're in the black's direction. Okay, so if this is true, then we want to set the piece on the not the en passant. Yes, the en passant square plus, depending if you're white. If you're white, then it's the en passant square plus 8 and -8 for black. Okay, and we'll set it to blank. Okay. All right. So let's see. Okay, it's dx. So we have to set up dx and dy. So right now it's only used here, so I'll just set it here. Dx dy equals xy diff from 2. Okay, and then just do the test. Xy diff of, let's say, E1 to E2. Okay, so if, actually EFG. Okay, so the x part is, the difference is 2, since you're going 2 columns over, and 1 for the y part, because you're going 1 square, actually -1, because you're going from 1 up to 2 and the index starts from 0. So it looks like this. So 0, 1, 2, 3, up to 8. And the next column is actually not to 8, to 7. And then we have 8, 9, 10, and so on. So if we're on one of the rows and we want to go up one, then we're going less. So the white part, we're subtracting 1 from it. All right, so let's see, expect xy. Oh, I think we forgot a parentheses or something. Okay, xy diff, let's write the xy diff. It's much faster the next time around. Okay, xy diff from 2. Okay, so it's going to be 2 div 8 minus from mod 8. Okay, so 2 minus from. Okay, so it should be simple. Wrong number of 2 for 3. Position for white, 7. 75. Oh, depending on the piece. Okay, so now the position looks right, but we need to clear out the en passant square. So for updating the state, we'll always clear it out. So en passant is nil, and we'll only set it if we make an en passant move. Oh, we have to use at here. Okay, so everything passes, so that's good. So when we take a pawn, we see that it takes away that extra pawn. And let's do some other moves. So if you let me think what the next steps are. We should be able to do move now. There's move and there's find. Okay, so when we do move piece, let's do the move validation in move piece instead of being in find. Okay, because it makes more sense because this is for move. Okay, so let's do rook moves. Okay, you may think that you may think that this is very similar to what we were doing before with move, except that we're not trying to do extra things. All we're doing is we have a coordinate from and to, so we don't have to find anything. But we're still going to do move validation, and I think it'll be greatly simplified than the previous version. So let's see. Let's take a look at the rook. So if you have a rook on e4, and actually we already did the rook. Actually, let's move the rook over here. Okay. And so let's just assume that, okay, let's do an illegal move. So if I try to do move piece e4 to d3, and this should raise an error. I'm trying to think, should it raise an error or should it return nil? I think I'll make it return nil. Okay. All right. Expected nil got something. Okay, great. So now we can put a little restriction on this. So Okay. Okay, so case piece when something, all right. Okay, so this is going to be a negative version of the ones that we wrote before. So piece. Okay, so we have dx and dy. We need the dx and dy now. Xy diff from 2. Okay. Case piece when. Okay, so rook. Then. Okay. If it's a rook, we're going to return nil if it doesn't match the criteria, which is dx does not equal 0 and dy does not equal 0. Okay, so that's our criteria. Okay, and it passes. Actually, maybe we can do it this way. Okay, that still works. Okay. All right, so mission accomplished for rook. Okay, so let's make a move for a knight. 94, and we say move piece e4 to c3, and that should be fine. So it should be the position knight c3. Okay. All right. And now with a knight on e4, if I try to go someplace that's illegal, then that should be nil. All right, let's get the knight working. When it's a knight, then return nil if dx absolute value, dy absolute value sort does not equal 1, 2. Okay, good. We should, okay, now what we did before was we treated bishop as black, so, okay, move piece from e4. Okay, this time we're not complicated by the fact of whose turn it is. We're just moving the piece. We don't care whose turn it is, because once we move the piece, we'll know whose turn it is. Okay, so e4 to f5. That should have the bishop on f5. Okay, and now for the illegal bishop e4, move piece e4 to e2, and that should be nil. All right, so this one is expecting it to be nil, but it's not. Okay, so when it's bishop, then return nil if the dx does not equal to dx dy absolute value. This should fail again because we need to make sure that it handles both sides. Okay, good. All right. We have the rook, knight, bishop. Let's say the queen. Queen e4. Move piece from e4 to e2. That should be fine. And that should give us a queen on e2. Okay, and now the illegal move, which is, let's say, d2. And that should be nil. Okay, so let's do the queen. And the queen is okay, so it's a combination of the bishop and the rook. All right. Okay, good. And now the king. E4 to E3. And the position is king on E3. And the illegal move is the king on E4, move piece E4 to E2. That's like 2 squares, so that should be nil. Okay, so let's do the king part. Okay, and that's when you get the dx absolute value, dy absolute value, and you specify the max of that, and that's greater than 1. And I like to have, I don't like using greater than, because this way I could always see that this is going to be more, so I put it on the right. Okay. Oh, nil. Okay. Return nil if the absolute value, if any one of those direction is greater than 1. Okay, so that's actually, it should work. And see the error here. It got nil. King, rook e1. Oh, so this is a castling move. Okay, I see. Okay, so it has a return nil over here. Okay, so you can castle. You can move more than one, but only under certain conditions. So this is the general case, and let's have the case for castling. Depending on the piece, white. Okay. If you're white, then okay, this is actually going to be a little bit more complicated. So okay, let's list out all the conditions. Okay, so this is the first condition. The second condition is if king is, okay, so from is e1 okay, so basically it's the same thing as this. Interesting. Okay, so I think that instead of it being one line like this needs to be broken up. So and we have the secondary move here, and we have this logic, and it's a shame to have. Okay, so I think what I'm going to do is I'm going to combine it. So I'm going to put this here for the secondary move. So there's not going to be a. So again, with the pawn, I'm going to do that as well. Okay, so if it's a king, all right, so okay, this is good. So if it's greater than then we need another test. So we'll say if actually, okay, so this is the condition. Right. Else, if you're going there, then you're moving the piece. Otherwise, return nil. Okay. All right. Yeah, this looks good. So if this is saying if you're about to make an illegal move, it's greater than 1, then we're going to test if to see if you're trying to castle. And if you are trying to castle, then we're just going to move the piece, the rook piece, because the king is going to be moved in this case over here. So this should take care of that. This is fine, and um, if none of these, then we know that this is an illegal move, so we just return nil. So this should handle that situation. All right. So okay, it looks like we passed that point. So now it's like we have a position where the king is on e4. We move the piece, and the king should end up on e3. And in this case, um, the update is not happening. Update of the state. Okay, so in that case, we can probably move that over too. Um, okay. Okay. So if you do a king move, um, actually we can't do this here. We have to do it at the end. Yes, and actually we have to do it at the end over here. Okay, so if you move your king at any point, then we're going to have to remove the king queen options here. Okay. Looks like we still have the same problem. Oh, it looks like the test is wrong. Right. The test is wrong. So actually, we didn't need to make the modification. So let me just undo this. I moved it from down here, so I'll just keep it back, put it back where it was. And the test is wrong. The test is if the king moves, then that's true. The castling is now going to be just king and queen without the capital K and Q. And here, okay, so everything should be okay, and everything passes. All right, so we now have all. It looks like we have all the legal moves. Oh, actually, wait a minute. We're okay. So we have rook, knight, bishop, queen, king. Okay, so now we need to do the pawn. E4. Okay. The process that we're doing right now is the same coding as we did before, but I think that the flow of code is a lot better. So if you take a look here, the logic, even for castling and pawns, it's all going to be in one function, and it's broken into actually two parts. It will be two parts once I get rid of this middle one here. And so you have all the pieces taken care of and all the special cases all in one spot instead of being broken down into three different functions. Um, and actually, I'll probably move this up in there too as well, but after I get everything passing. Okay, so if you have actually E2. So if you have a pawn on E2 and you move from E2 to, you can move from E2 to E3. Okay, and you end up with a position where you have E3. Okay, and if you have a pawn on E2, you move the piece from e2 to e4, then you end up with a position e4, but the en passant square is going to be on e3. Okay, we're not modifying the term, just the state of the others. So en passant. Okay. Oh, missing bracket here. Okay, so we're able to move the pawn 1 square or 2. Let's try to make an illegal pawn move. So you have a pawn on e2 and you try to move to c3. e2 to c3. And that should be nil. Okay, another pawn move. You have an e2. Okay, so now we deal with blockades. So if you have a pawn on e2 and a black piece on e3, e3. Okay, and you try to move from e2 to e3, this will be nil. And if you have e2, e4, and you try to move the piece e2, e4, that will be nil. e2, e3, and you try to jump to e4, that would also be nil. Move this up here. So we have, if you have a pawn, you can't move 1 or 2, and okay, and also you can't move diagonally as if you were going to capture. So e2, you cannot go to. Actually, that's already done with c3. Okay, so I'll skip that. All right. So now we deal with captures. So if you have a pawn on e2 and a pawn on black pawn on c3, actually, and you try to move piece from e2 to c3, then you should get a position where you have e2, c3, and yeah, I think that's it. Okay. E2, c3. Okay, let's think about any illegal situations. Okay, so another thing that you can't do is you can't capture your own piece. So we'll do that with a generic piece, such as a rook e4 and a bishop e3, and if I say move piece from e4 to e3, then this should be nil. All right, so let's get started on this. So this is moving from e2 to e4, so 2 squares. So let's handle the case of the pawn. As for the king, this is the king move here, so I'm going to take this and put it with the king right there. Okay, and I'm going to create a section here for the pawn, and let's see, put this here as well, and we don't need this anymore. Actually, this it wasn't for the pawn, right? It was for the rook. Okay. Okay, so put this with the rook. So if the rook moves, okay, so we'll put this at the end here after. Actually, we'll put it here before. Okay, return nil if that happens, otherwise we'll mark it up. And let's see, for the, this is secondary move for the pawn. Okay, so we don't need this anymore. Okay, we can just, that's the only one state. And let's see, when P. So this is for a pawn, secondary move for the pawn. So we don't actually have a pawn move, so I'm just going to put it here and say when pawn. Okay. All right, so clean things up a little bit. And so let's see, pawn. Well, we'll set the en passant later. Okay, so let's take a look at this. So this is for the en passant, and we need to clear out the en passant if we make a move that's not a pawn. So 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 if piece is a pawn, we'll just say upcase here. So if it's a pawn and dy absolute value is equal to 16, that means you jump to then this else part, actually we don't need an if else because we can actually use this as the condition here. Okay, and this and is really and. Okay, so if it's a pawn and you jump 2, then your en passant square is going to be, depending on the piece. Okay, so if you're white, then it'll be a 2 square minus plus 8. Might as well bring the 2 out here. 2 plus 8 or negative 8. Otherwise, it's going to be a null. Okay. So this, okay, e2 to e4. So we jump 2, and the en passant e3 should have been set, but it's set to nil. So, oh, this should be 2 if you jump 2 dy. Okay, so we now are in our first, actually let's take a look at the code now. This code looks a lot nicer. Everything that belongs together belongs together. So here's the rule for the knight, here's for the king, and it does the secondary move and checks for castling as well. So everything is here instead of being in all different places. And so if I want to find out the rule for castling, I just look for the king and look for king side castle or queen side castle. So I like this a lot better. Okay, so let's try to finish this off, and this will be a good stopping point. Okay, so we have, let's see what the error is. Oh, okay, so yeah, a pawn try to move diagonally. Expected nil but got something. So we need to make a rule for the pawn. So pawn. So let's think of some illegal move situations. Actually, we need the dx and dy, and actually we have dx dy right there, so we don't need to get it again. So we have it, and we could just split this off. Okay. This is en passant, and this is one of the cases. So the next case is moving one square or two squares. So if you're moving okay, so if dx is equal to 0, okay, so if you're moving straight, then what you want is the square in front of you, actually the target square, should be blank. And if it's not, return nil if it's not. Okay, so it has to be blank. Some other ways that it'll be illegal, dy. Okay, now it depends on dy now. So return nil if actually if the dy is greater than 1, absolute value. So if you're jumping more than one square, then actually let's put a case here. So if dy absolute value is equal to 1, then everything's okay. Then okay. Okay. If actually all we need to do is check for the square. So we just need this. That was the only thing that would stop it from being illegal. And dy absolute value 2, okay. Okay, so this is the case where it's 2, and from is equal to, if you're white, it'll be 6, otherwise 1. These are the home rows. Then it's okay. So if it's not one of these, so else. Okay. Actually, this condition, okay. So this is where we want to return nil. So basically we have a positive version of the code, and so we just need to turn this into a negative. So so we can just do that. We can just say return nil if dy absolute value does not equal 1 and dy absolute value does not equal 2, or from 8 does not equal white piece 6, 1. This is using De Morgan's law. Okay. All right. Return nil if the absolute value is not 1. Okay. And if it's not 2, pretty sure like there's probably an easier way to do this. And also that the if you pass this, then return nil if board 2 does not equal empty. Okay. All right. Expected nil, but E2 to E3, E2 to C3, 2 to C3. Oh, that's because we're missing an else here. In this else clause, we just return nil. Actually, see, this is capturing en passant. We need to handle the case of capture. So, well, let's just see. E2, E3, this says you're not allowed to jump over. And that's actually a general rule of pieces, that you can't jump over pieces, except for a knight. So I'm going to say for anything as a general rule, return nil if the path is not clear from 2. Okay. All right, undefined method path clear. So let's write a test for path clear. And that will look like, actually, path clear is part of chess helper. Okay, so actually it's not part of chess helper because it requires the board. Okay, so we do need to have it out here. Path clear. So if you have a position where rook is on e4 and you say path clear from e4 to e2, this should be true. And position with rook e4 and rook e2, path clear from e4 to e2 should still be true. But if you have a rook in the way, or e4, but there's a pawn in the way of e3, you say path clear e4 to e2, that should be false. And for a knight, if you have a knight on e4 and a whole bunch of stuff, so d3, d4, and d5, and you see path clear from e4 to c3, then that should be true. All right. Okay, so we're off by a parenthesis somewhere there. All right, so no method path clear, so let's write that. Okay, so path clear takes from and to. Okay, so it's going to return false if it's not on the diagonal. So actually, let's get the dx and dy here. So, okay, if Okay, so if it doesn't move like a rook and it doesn't move like a bishop, then we're just going to actually return true. That's for our case of the knight. Yes, the path is clear because it's not one of those straight conditions. So once you have the straight conditions, then let's figure out what all the steps are. So okay, so we have dx and dy, and we can figure out what the d is dx spaceship 0. So dx compared with 0 plus dy compared with 0 multiplied by 8. Okay, so we have a direction. So now we can just step through. So we can say from step 2 in steps of d. And all of these, okay, index board is equal to empty. All right. Okay, so rook e4 to and we have to subtract the from and to. So we can actually add d to this and subtract d from this. Okay. Okay, so that it looks like that passed. So let's take a look at this one. E2, there's a pawn on C3, so this is, oh, actually this is, you should not be able to capture this because it's too far away. Okay, so the test is wrong. Okay, so let's correct this. It should have been D3. D3 would be close enough to do a capture, so and the position should be D3. All right, so you get E2, D3, E2 to D3, and position should be D3, and it's failing. And okay, so spec 80. All right, so let's take a look. So we'll just tap into this. Okay, pretty convenient way to set up a debugger, and we'll require the debugger. Okay, and then we can just It's interesting that it seems to be stepping all the way through. Otherwise, stopping at define method. Okay, it's very interesting. Okay, so I'll just try to figure this out logically. Okay, so going from E2 to D3. Oh, right, of course. The reason why is because we didn't write the code for it. That was one of the things I was doing. So here, if the dx absolute value is equal to 1, this is when it's a capture. Then we do a test. Actually, in order to do a capture, the dy should be equal, if you're white, it should be -1, otherwise a 1. Then, and the target piece is not, actually is not empty. Okay, so that means you are capturing a piece. Then you don't have to do anything. Okay, so I'll just put a note here saying capturing a piece. Okay, so we're up to the next one. So we have a problem with rook e4, bishop e3, and this is saying that e4, e3. So you can't capture your own pieces. So let's do that. So along with this, some general rules is return nil if the color of the piece is equal to the color of the place where you're going. All right. And this will bomb with color, so let's write the test for color. Color of a rook, let's say, to be white. Color of lowercase r is black. Color of empty square is nil. Okay, so let's write color. Oops, forgot at the end. All right, everything passes. So we have some tests here. So I think this is a pretty good stopping point and a good point to reflect. So the code actually, I think, looks a lot cleaner. So these are the tests, and these are we're not quite done, but and for move piece, this is what the code looks like. Even though it looks a little bit messy, it really isn't, because I could move these things into a different function, but then you have the hassle of making sure you're passing in the right parameters and everything. Actually, that might not be a bad idea for some of these more complicated ones. Let's see. So there's some pawns, and okay. So okay. So the big benefit here between this and the other one is that I don't have to go searching for where to start modifying the code. I can go, it's all in one place. So that's the thing I really like about this. And if I really wanted to, I could just organize this a little bit better, but logically, it's just much more clear to me. Because this doesn't handle switching turns, and it doesn't handle looking for checks and things like that, and filtering out the next move, which we will do. And so I think this is a good stopping point, and so I can commit the code, and we can start working on moving forward with this. And I think that I really like this a lot better than the previous one.